This is the new FOCA A1 candy. And this is my screen. I guess I can say it's pretty accurate, like +5 -5 seconds. And in this video we're going to talk about the idea and the manufacturing behind this assembly. But first, why is it locked? I'm sure that if you watched the previous video that I posted, you saw that there are two versions, the locked and the unlocked versions. But to answer that question, we need to look inside this thing. Like, for real. This is what the assembly looks like behind the scenes. Simply a mess. Wires everywhere, an unbelievably weak prototyping PCB, and a button. Actually, let's rewind a bit. This project was initially designed around the Raspberry Pi Pico W so that we can have the internet. But for some reason, I would either get bad SEL pin, which I knew how to fix by the way. It's just that, you connected the SEL pin to the bad pin. Or Erno 5EO, which I have no idea what it means, but I had a lot of problems with it. And I don't know why it happened, since I checked all the connections a dozen times before, moving to the Arduino. And then I said, if the Pico W is not working, then perhaps it's little brother, the simple Pico, would work. Long story short, that resulted in exactly the same results and exactly the same errors. And then I said bye Pi, Arduino bye. And I found an Arduino Nano scattered around my components. And guess what? That finally worked. And it worked amazingly. Just one problem, or actually two. I ran out of green PCBs, so I had to use these brown PCBs, which by far were the worst ones I've ever seen in my life. Why? Just try soldering anything on it and you're going to see that these pads, these little copper I think pads that sit on it, are just going to snap out of the PCB. And voila, your brand new prototyping board is now unusable. This could also be because it's just a one-side PCB. As you see, there is metal just on one of the sides. This one doesn't have metal, whereas this one is, I think it's aluminium. It looks like aluminium. It has true holes, which means there is aluminium or whatever this metal is on one side and on the other side as well, which improves the adhesion to the board. And by the way, this one also doesn't melt as quick as this one does. Also, the Arduino Nano runs at 16 MHz, whereas the Raspberry Pi Pico at 133 MHz. And that's like 8.5 times faster. And yes, that's the biggest trade-off I had to make in this project. Give up speed, but make it work. At least to some degree. Why to some degree? Because in the code, the RGB LED was set to be on for the locked version. But, my candy just fell on the ground and, yeah, it stopped working. And no, that's not because of a manufacturing problem, because I did my best making this work, but because the code for the locked and the unlocked versions are the same. The only difference is that the unlocked version allows you to push the button on the PCB, whereas the locked version doesn't really have that option. What essentially happens when you press the button is that a variable gets incremented by 1, and if the number that results from that is odd, then the LED is off. Vice versa, if the number is even, it's going to be on. So I guess it pressed itself against the wall somehow. Other than that, I think that an LCD would have been a lot better inside the body of this thing. And I'm saying this because it's kind of hard to see on something that is, I think it's 0.96 inch. Whereas this, if you put it vertically, this by the way is a failed print, it's going to look a lot better, and it's also going to have a much bigger surface. And I'm saying this even though it would create a monstrous cable management problem, since you either get like 1000 cables inside this thing, or you buy an I2C module, which, although not much, takes from the already limited space inside the module. On the temperature sensor, I could only know that I would use one of those DHTs instead of the one provided with the DS3231 clock module, because not only the measurements would be a bit more accurate, but we could also get a humidity. Speaking of the temperature sensor, this little hole right here was initially designed for the DHT11 sensor, by the way. Excuse me. But later I said, how about a movement detector on the candy? And I said, yes, that would be a great idea to place a movement detector on the candy. So, we placed a movement detector on the candy. And the DHT was out of the plan. And said, I'll just rely on the DS module to do all the work for us. Speaking of the movement detector, I was planning to make it stop the entire module, the entire candy from operating if it wouldn't detect any movement for 30 seconds. 30 minutes, which would have been just a simple calculus with using the millis function of the Arduino. The problem is, I kind of hurried, because my deadline was on the 31st of December, and I missed two things in this creation. One, making a hole for the button, like in the advertisement you saw. This is the locked version, not the unlocked version. And adding the movement detector code. Because theoretically, there is some code inside here, but right now all it does is that it says yes if it detects anything moving, and no if it doesn't detect anything moving for 10 seconds. And now the last module is the HT05, which works, except It doesn't. Out of the about 11 days I worked on the candy for, 2 entire days were dedicated towards the HC sensor. But did it work? If you mean a nice flickering from the sensor and the ability to connect to it with your phone, which by the way I'm going to test right now, or I can do something else. First of all, let's plug this candy in. Okay, yeah, I might just... Okay, and here we are on the candy with our computer. And now if we go over to Bluetooth, well, we should be able to see something. Yes! I forgot a pin. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and paired. You can see we got the HC module inside here working. But you know, you can't really do anything with it. This is just for fun. Please don't look at me like that. And as you've seen, it does a really nice flickering. Actually didn't see that, but that doesn't matter. And you can connect to it with your phone. But can you do anything with it? Like, control the Arduino in some way? And the answer to that is no. Either me, the module, or the PCB, which might actually be the case for all this, was the problem. And well, I guess that's all for now. I'm not sponsored by them, but if you want to get these components, and if you live in Romania, I purchased everything from Clash.ro. That's where I got all the modules from, and well, they work pretty good. Also, if anyone thought of it, the FOCA A1 is not yet a product. Yet. I said yet. So, unless there is a special demand, that's it for now.